Once again, you are welcome to our SHS 3 Core Mathematics lesson brought to you by the Center for National Distance Learning and Open Schooling. I'm Lucy. In our previous lesson, we learned about implications. In this lesson, we are looking at the final lesson on logical reasoning, and we shall look at validity of arguments. By the end of this lesson, you should be able to use the Venn diagram to determine the validity or otherwise of implications or conclusions. Again, you should be able to draw conclusions from statements made using the implication sign. Now let us look at what a valid argument is. An argument is valid if and only if the conclusion follows from the premises. The premise of an argument is always assumed to be true. It is also important to note that the truth of the conclusion is irrelevant when testing for the validity of an argument. The validity of an argument can be determined using three main things. We may decide to use equivalent statements. That is, if P implies Q is true, and not Q implies not P is also true, then we can conclude that P is equivalent to Q. B, the chain rule. And then C, Venn diagram. Let us look at the first one. Let's see how we can use equivalent statements to determine the validity of an argument. We can deduce the validity of an argument using the fact that if P implies Q is true and the contrapositive, not Q implies not P, is also true, then we conclude that P is equivalent to Q. We want to take an example. Consider the following statements. Statement P, Roland works hard. Statement Q, Roland is rich. Now let's look at the implication. If Roland works hard, then Roland is rich. If P implies Q, which of the following statements are valid? I, if Roland is rich, then he works hard. I, if Roland is not rich, then he does not work hard. I, if Roland does not work hard, then he will not be rich. We want to look at the solution. In our previous lesson, we stated that P implies Q means Q is true only if P is true. I hope you remember that. We can also write the contrapositive as not Q implies not P. That is, the negation of the second statement implying the negation of the first, where not P and not Q are the negation of the statements P and Q respectively. So let's look at I. If Roland is rich, then he works hard. This means Q implies P. Remember, we said P implies Q. So if we are using Q implies P, we are talking about the converse. Therefore, this statement is not valid. Let's take the second one. If Roland is not rich, then he does not work hard. This means we are saying the negation of Q implies the negation of P. Therefore, this statement is valid. The third one. If Roland does not work hard, then he will not be rich. This means that the negation of P implies the negation of Q. But no, that is not what we have said. So this statement is not valid. I hope you understand. Let's take another example. Consider the following statements. Statement P. Amma has measles. Statement Q. Amma is in the hospital. If P implies Q, state whether or not the following statements are valid. Let's look at the first one. I. If Amma is in the hospital, then she has measles. I. If Amma is not in the hospital, then she does not have measles. I. If Amma does not have measles, then she is not in the hospital. Let's look at the solution. P implies Q means Q is true only if P is true. The contrapositive is given by not Q implies not P, where not P and not Q are the negation of the statements P and Q respectively. So for the first statement, if Amma is in the hospital, then she has measles. This means we are saying Q implies P. But the original one said P implies Q. Therefore, this statement is not valid. Now, let's move on to the second one. If Amma is not in the hospital, then she does not have measles. Here, it means we are having the implication not Q implies not P. That is the contrapositive. And this statement is valid. I hope you are getting along with me. Let's take the third one. If Amma does not have measles, then she is not in the hospital means not P implies not Q. But no. That is not what we have taught. We have not said that. Therefore, this statement is not valid. Good. Now, using the chain rule, we can also determine the validity or otherwise of arguments. If 2 is less than 3 and 3 is less than 5, we can conveniently conclude that 2 is less than 5. In the same way, if A is less than B and B is less than C, we will say A is less than C. In fact, this is the chain rule. The chain rule states that if P implies Q and Q implies R, then P implies R. Symbolically, we can write it like this. P implies Q, and Q implies R. Good. We are going to use this chain rule to solve this example. Determine whether or not the following arguments are valid. Statement P. Lagos is in Ghana. Statement Q. Ghana is in East Africa. Statement R. Lagos is in East Africa. Let us take the solution. The first premise means P implies Q. And for the second premise, we have Q implies R. So by the chain rule, we would conveniently conclude that P implies R. That is the statement, Lagos is in East Africa. Therefore, the conclusion follows from the premises, and the argument is valid. Remember that the truth of a conclusion is not relevant when testing for the validity of an argument. Good. Let us take the third one. We can also use the Venn diagram to determine the validity or not of an argument. When drawing a Venn diagram to illustrate a given statement, you must look out for the following. These are keywords that will help you draw your Venn diagram. I, the word no, or never, or do not will mean disjoint sets. I, some, most, not all. These words would mean intersection of sets. And then I, all. If so, then so. That will mean subsets. I want us to use an example to illustrate this. So let's take example 4. Consider the following statements. Statement P. All hunters are men. Statement Q. There is no hunter who does not use a gun. A. Draw a Venn diagram to represent the given information. B. State whether or not each of the following is a valid conclusion from P and Q. I. Men who use guns are hunters. I. All men use guns. I. Men who do not use guns are not hunters. Let's take the solution. In drawing a Venn diagram, we are going to use some sets to represent the various circles that will go into that Venn diagram. Let mu represent the set of people. M, the set of men. H, the set of hunters. And G, the set of men who use guns. Now, the position of K on your Venn diagram means you are a man, you use a gun, but you are not a hunter. Again, I believe you can see the position of N. That means you are a man, you use a gun, and you are a hunter. Now, once we can place any of these elements in more than one position, we will conclude that the argument is not valid. Now, let's see the Venn diagram. On your Venn diagram, you realize that the position of K represents men who do not use guns, who are not hunters. Now I, men who use guns could be in any of the positions marked N. Hence, men who use gun may or may not be hunters. Therefore, the statement men who use guns are hunters is not valid. I. The position of men are marked K in the Venn diagram. We notice that the men in the region between M and G, where our K is, do not use guns. Hence, the statement all men use gun is not valid. I hope you are getting along. Let's take the third one. Men who do not use guns is the region between M and G. The region is disjoint to H. Hence, the statement men who do not use guns are not hunters is valid. Well, I hope you understand. Now let's take another example. Example 5. Consider the statements. Statement P. Martin trains hard. Statement Q. Martin wins the race. If P implies Q, state whether or not the following statements are valid deductions from the given statement. A. If Martin wins the race, then he has trained hard. B. If Martin does not train hard, then he will not win the race. C. If Martin does not win the race, then he has not trained hard. Solution. This question did not restrict us to any particular formula or method. So we want to use implications or Venn diagram to solve it. We can use implication to solve it. We can also use the Venn diagram. I want to show you how to use any of them. So we are going to use each of them to solve this particular question. We learned under implications that P implies Q is false only if P is true and Q is false. The statement P implies Q is Martin trains hard implies he wins the race. So A, if Martin wins the race, then he has trained hard. This means Q implies P. The statement is not valid because we have not been told that Q implies P is true. That is, P and Q are not known to be equivalent. B. If Martin does not train hard, then he will not win the race. This means not P implies not Q. The statement is not valid because we were told that P implies Q. And we were not told. This does not mean that not P implies not Q. Let's take the third one. If Martin does not win the race, then he has not trained hard. That is, not Q implies not P. The contrapositive. The statement is valid because P implies Q means not Q implies not P. Good. So we can also use the Venn diagram to solve this. So with this same question, we want to use the Venn diagram. Let U represent the set of people. T, the set of those who train hard. The set of people who train hard. W, the set of people who win the race. Those who win the race. And then the element M represents Martin. From the Venn diagram, we can conclude the statement, if Martin wins the race, then he has trained hard, is not valid. II, the statement, if Martin does not train hard, then he will not win the race, is also not valid. And then III, the statement, if Martin does not win the race, then he has not trained hard, is valid, given the position of M in the Venn diagram. I hope you understand, and you can use the Venn diagram to determine the validity or otherwise of an argument. Now let us take example 6. Consider the following statements. Statement P. If students work hard, they will pass their examinations. Statement Q. If students pass their examinations, they do not sleep in class. A. Draw a Venn diagram to represent the statements P and Q. B. Deduce whether the following conclusions are valid or not. I. Ellen does not sleep in class, so she is hardworking. II. Ni does not pass his examinations, so he sleeps in class. III. Now works hard, so he does not sleep in class. Let's take the solution. Again, we will define our sets. So let U represent the set of students. P, the set of students who pass exams. H is equal to the set of students who work hard. And S, the set of students who sleep in class. Now, from the Venn diagram you can see on your screens, the statement Ellen does not sleep in class, so she is hardworking, is not valid. That is I. See the position of Ni on your Venn diagram. Ni does not pass his examinations, so he sleeps in class. Ni can also be outside the two sets, so this statement is not valid. The third one, now works hard, so she does not sleep in class. This statement is valid. Good. Let's take another example. Illustrate the following statements in a Venn diagram. All good literature students in a school are in the general arts class.
Action.
II. Use Venn diagram to determine whether or not the following are valid deductions from the given statement. A. Vivian is in the general arts class. Therefore, she is a good literature student. B. Audu is not a good literature student. Therefore, he is not in the general arts class. C. Kweku is not in the general arts class. Therefore, he is not a good literature student. Let's take the solution. In order to draw the Venn diagram, we will let U represent the set of students. L will represent good literature students, the set of good literature students. And G will represent the set of general arts students. So, from the Venn diagram, the statement Vivian is in the general arts class, therefore she is a good literature student, is not valid. Audu is not a good literature student, therefore he is not in the general arts class. This statement is not valid. C. Kweku is not in a general arts class, therefore he is not a good literature student. This statement is valid. If you have come along with me this far, then you have done very well. Remember that there is nowhere in my statement that I said something is invalid. I always said it is not valid. So when you are answering your questions, you do not say invalid. Remember, invalid is a different word altogether. We are talking about an argument that is valid and an argument that is not valid. Having gone through these exercises with me means you have solved standard examination questions. In this lesson, we have learned that A. An argument is valid if and only if the conclusion follows from the premises. B. That the premise of an argument is always assumed to be true. C. We have also learned that the truth of the conclusion is irrelevant when testing for the validity of an argument. Finally, D. That the validity of an argument can be determined using I. Equivalent statements. That is, if P implies Q is true and not Q implies not P is also true, then P is equivalent to Q. Also, we said we can use the chain rule to determine the validity of an argument as well as a Venn diagram. Well, once again, we have come to the end of our lesson. And this brings us to the end of our lessons on logical reasoning. In our next lesson, we are going to take a very interesting topic which is new to the syllabus. In fact, it is new to the examination syllabus called matrices. I hope you will join me. Until then, it's goodbye.